I'm just going to go through a bit of a recap on how we might do a lot of the questions we've done so far, and then I want to get on to percentage increase and percentage decrease. All right, so I'm going to do quite a quick snapshot of the questions we've done so far, but people that haven't been here or for whatever reason, you can go back over and have a look at those quick things. Okay, so I just want to go through this. Stay alert, because I might say, how do you do this? So express these fractions in simplest form. Basically, anytime you see a number with a percentage following, what has to happen to the number and the percentage following, Tani?
I don't really know what to say.
Yeah, express as a fraction in simplest form. Anytime we see something like this, what has to happen there, Jazz?
I don't know.
Ellen?
When you put like a 2 in big and then like 1/2.
Good try, not quite. Good to see you having a go.
Put it as a decimal.
Yeah, it asks you to put it as a fraction, that's all. So not just yet. Maddie?
Is it over 100?
It's always over 100. So whenever you see something like this, then it's the number, and remember it's over 100. Okay, hopefully we recall that, but we're not quite there. 310%. As a fraction, 310% looks like that. 310 over 100. Yeah? Tani, does that make more sense now?
Yes.
8 over 100. Okay, so whatever the number is, it's over 100. And remember that we use the percentage sign, the 1, the 0 and the 0. Hopefully that reminds you. It's got to go over 100. All right? What do we do here, Liam, when it's 87.5? Sure, it says 87.5 over 100. That should be your first thought. How do we go about solving that from there?
87.5 over 100.
Awesome. That's 87.5 over 100. Emily, can we simplify this while it's in decimal form?
No.
We preferably not. We try and get it to a whole number. Tish, what would we do there?
I don't know.
You don't
No.
know?
Times it by 2.
Times everything by 2, so we get this top line into a whole number. Times that by 2, and what you do to the top must do to the bottom. 87.5 times 2. Isaac?
175.
175. And Greg, 100 times 2? 200. Are we finished yet, Damo? We could be finished, but why aren't we finished? What is it in the question, Damo, that says we're not quite finished yet? It's not in simplest form. Okay? You look at this last number and the last number here, and you see that it's a 5 and a 0. Your 5s could go into all of that, but you try and find the biggest number possible. And the biggest number possible, hopefully you can see there, is if you divide that by 25 and divide that by 25. 175 divided by 25, Caitlin? How many 25s in 175? Do it with me. 25, 50, 75, 100. 7? How many 25s in 200?
8.
Yeah. 7/8. We've answered the question there. It's incredible, isn't it? We only did this maybe a week ago, yet we struggled with them. Interesting. Maybe we need to go back over them when we are preparing for our test. Express as a decimal. How would we go about this question, Will?
Divide by 100.
Okay, good. Straight away, you see that there's a number followed by a percentage sign. So it must be divide by 100. 44 divide 100. Is it finished yet? Express as a decimal. That doesn't look like a decimal to me. So what would we have to do there, Luke? Does that look like a decimal to you? No. No? What could you do? Maybe with your calculator. Actually do it. 44.
Divide by 100.
44 divided by 100. Yep. And what does that come out to be? 0.44. See how we're reading the question to get our answer? Okay. How will we go about this, Reese? 6.75%.
Just divide by 100 and we get the percentage.
Divide the 6.75 by 100. Absolutely. Again, 6.75 divide by 100. What does that give us?
0.0675.
0.0675. And the last one, Tish, is 0.7%. How would we go about that?
What are we reading?
0.7%.
Divided by 100.
Divide by 100. And what I'd like us to start to be seeing is that there's 2 zeros here. Okay, so we've got to move that decimal place 2 places. It comes in there. We replace it with a 0. 0.007. Okay. So there are some shortcuts, and I'm hopeful that obviously some of that's a bit of an issue for some of you. Maybe get a highlighter, go back to those questions. All right, as we're doing it now, scrub on it. Scrub on those questions to say, this is the stuff I need to learn. All right, but if you're sitting there and going, I understood all that, well, that's no worries, I suppose. I'm just not sure we all did. Okay. So you got a couple of secs to scrub on your page if you needed to. These ones here express as a percentage. If I said to you, Damo, you got 13 out of 15 for a test, more often than not, your test would come back looking like this, wouldn't it? And it'd be some sort of percentage. What is 13 divided by 15 there? Sorry. 0.86 times 100 is 86%. Okay, you would all be, don't tell me you're not, you would all be familiar with getting test results or some results back looking like that. Okay? What I would like you to try and remember with this is it's the same thing. 15 out of 20, 38 out of 40, 11 out of 25, 18 out of 30. It's the same process, okay? This one you'd see easy, 38 out of 40 times by 100 because it's expressed as a percentage. 18 divided by 30 times by 100. So if in doubt with any of these questions, treat them a little bit like you would with your any result that you get back for math, science, PE, whatever. Okay. Lily scored 76 out of 80 for a physics test. What was her percentage? That should be really familiar to you. It's just these ones which aren't in the form of a test result that sometimes could bring some confusion. Think of them as a test result, and that may help you with that. Are there any questions with that? Or did anyone struggle with any of them? Which how do we remember how to do this one? What are some key ideas that we have to remember in order to achieve these ones? Ben, what are some things we need to remember if we just look at 55% of $8? What are some key things that we need to remember? If we read from left to right, if we read from here and go across, all right, what's the first thing we need to remember? We've explained it prior in this session. Yeah, have to, what? What does 55% look like as a fraction? Yeah, what does it look like as a fraction?
55 over.
Yeah, excellent. So 55 over 100, we just spoke about it. Whenever you see a percentage sign, it goes the number over 100. What does of mean, Damo, in maths?
Multiply.
Multiply. Excellent. So 55 divide 100 times by 8. Can you do that, please, Damo? Or Tani, have you done that? 4.4. 4.4 Do we leave it at 4.4? No, we're talking about dollars. So it must be $4.40. Okay. So again, there's some things we should know and pick up automatically now as a result of some of this. The rest of those questions, again, should be pretty straightforward for what you've done prior in maths. And the unitary method I went through the other day. So I want to go to new learning, which is percentage increase and percentage decrease. Now, whenever we have a question with percentage increase and percentage decrease, all right, we've got to look for the language in the question. The language we're looking for is seen here. Okay, a fruit grower picked 1720 kilograms of apples last year. This year she expects her crop to be 20% bigger. All right. Whenever you see the words bigger or increase or larger, any of those words will see you add in this section. Okay, percentage increase or percentage decrease. You subtract when you see the words decrease or less or something like that. Okay? So the question being, she expects her crop to be 20% bigger. Bigger means to add. How many kilograms of apple does she expect to pick this year? Okay? So last year she picked 1720 and this year is going to be 20% bigger. So your first thing you've got to find is 20% of that original amount. Alright, we just went through that. 20% means 20 over 100. Of Liam means 2 times 1720. Okay? So, Will asked me, do I need to do this? 20 over 100 times by 1720 in here. Does he need to do that? No, you don't need to do that. But what I'm saying from before is not everybody's understanding that 20% is 20 over 100. Okay, so maybe you do need to. That gives you 344 kilograms, 344 more than last year. Okay, so if 1720 was last year, she's expecting to get it bigger, therefore add 344 to this year's crop, so to 2,064 kilograms this year. And if you look at, it's good how those squiggles just go on there. If you look at some of the questions below, question 3 there, last year there were 2,075 students in South Australia enrolled in Year 12 Physics, and enrolments this year decreased by 4%. How would we go about this, Brooke? Last year then.
Thing, but you take it.
Yeah, you do the same thing, but you take it. That was a good, quick way of getting out of it. Absolutely. Jazz, how could we go about this calculations-wise? Find the decrease in enrolments.
You do the 4 thing over 100.
4%, yep. 4 over 100.
And then you minus the 2,075.
You minus them. Tish? You think about it before you spit out an answer. Find the decrease in enrolments. Last year there were 2,075 South Australian students enrolled in physics. Enrolments decreased by 4% this year. Find the decrease in enrolments. So what are we finding 4% of? Oh, we're finding 4% of, Maddie?
The 2,075.
We're finding it of 2,075, so it's times, isn't it?
Yeah.
All right, does that make sense, Tej?
Mm-hmm.
Does that make sense, Jazz? So that looks like this. 0.04 times 2,075. What does that give us? 83. So there's 83 less enrolments now. Find the decrease. There's 83 less enrolments. What do we have to do over here, Greg?